Good morning, guys. Happy Saturday. Um, I'm just chilling. I'm awake. Voice a little bit deeper, only because I woke up. This is gonna be open office hours period. Just chilling, relaxing. We can discuss anything you'd like to discuss. Q&A. Do I have anything prepared? Yes. So, I guess I'll just go over random topics that I have that I've just been going through. Um, Allow me to pull it up real quick. So, I was evaluating the characteristics of the SU-57. What's up, man? What's up, man? So I was evaluating the characteristics of the SU-57 just because I figured we're going to eventually need to be able to counter that device. So just because I gave up the counters for the F-35, I'd like to give up their counters to the SU-57. So the 57, it looks to me like they're going the entire opposite direction. So the United States went for kind of like radar supremacy, so you can't really track us. The SU-57 is going kind of like the route of the F-117. What that means is like they're not using radar coating, radar absorbent materials. They're not going for metamaterials. They're going for, regular metals, regular strong metals, so they can up their weight and up their structural strength. So the SU-57. Let me use TikTok to mirror. And if you guys want to just join on, I can let you guys join. I don't really care. I want to hear people. I want to see people. Let me click settings. It's somewhere here. So I don't know how to mirror it. I was able to do it last time, but I guess I can't this time. So SU-57, they're going all out. So what that means is, based off the curves of the top, they're trying to use what's it called? They're trying to polish the structure on top so that if you try to get a radar track or try to track it from on top, the waves will just reflect off in angles that are not advantageous, that you cannot track it. But if you are able to target the bottom is actually has a lots of hard points and lots of angles. So the bottom of the SU-57 is very vulnerable to radar track. However, if you are at any angle on top, it's not likely. So it seems to me like that's their strategy. So the Russian strategy is able to travel at Mach 4. They claim Mach 5 plus, but I don't really believe that. So they can travel reliably at Mach 4 at between cruise to high altitude. What this means is that they're trying to basically do like a low-level bombing. So they travel low level, mock it out, bomb at a distance, but then fly back. However, anytime they turn their angle and they show, once again, that bottom hard point, vulnerable as hell to radar tracking. But all they got to do is then finish the turn and then keep going. But once again, like you don't, it's SU-57 has limited characteristics that it's not a superior fighter. It is definitely meant to be an evasive bomber that basically cannot get targeted from above. So they're safely able to do low-level flight. However, not safely, because as we saw in the Russian and Ukraine conflict, even with the Su-35, the Su-35 was able to be shot down by a shoulder-mounted weapon. So once again, the Russian strategy is just trying to prevent what's called above tracking, which is, I guess useful, but all it does is really give them what's it called, radar reduced signature, and for any targets above like an what's it called, EWAC or something, EWAC, like those aerial defense electronic warfare vehicles that can actually radar track people. It would only give them defense against an AWAC if their angle is not at the because there are still curves on the Su-57, and those curves can be targeted, can be tracked. All right, so what do you guys like to discuss right now? Because that was just basic plans, but we're open right now, open hours, open office hours. I just want to discuss with you guys. What I really wanted to do today was just to talk about consciousness, but to offer services for like consciousness tracking, consciousness sort of like understanding. So interesting. As we swap to that, now we get less viewers. Quiet, whatever. It'll be whatever it is. Be what it is. So we can do engineering, but engineering isn't really, too big right now. So I'd like to discuss what I have and my knowledge for you guys in any other purpose. Um, Ask questions like this thing says, Q&A thing, deepest questions. That was just meant to sort of rip on the fact that there are people that are like, you know who he is. Well, you see, the nature of life is actually, there is no known, if you know what I mean. Like, yeah. That's the sort of questions that I'd like to answer, because I actually do believe we have a reasonable, not just reasonable, we have the exact approximate solution. Yes, there are these strange characteristics of like quantum mechanics, but it's not really quantum mechanics. That's what I wanted to do right now. I wanted to discuss with you guys just various problem spaces, various things that I've been doing in my time, my free time. So right now, what I'm trying to do, I'm trying to help code a video game. I'm trying to code a video game. So I looked up various procedural generation techniques, and the one that I think is the most conducive with my algorithm, the standard model variation for finding things and bitwise decay patterns. The thing is, these decay patterns only work for pre-solved calculations. So if we're trying to generate things that are not pre-solved calculations, they break down. They're not necessarily as useful. But what I'm trying to do is use something called the wave function collapse model for coding procedural algorithms. I just wanted to discuss, I guess, various aspects of the game that I think would be interesting. So what I have to do is we have to first generate a. So there's two different things, two different methods that I'm trying to do. So for a basic desert warfare kind of map, that one is just a basic terrain map. We generate with kind of Perlin noise, and then we stamp things on top. That I understand how to do. So we can generate just a terrain that we think is useful to host a battle. We stamp things on top, such as the mountain. We would stamp those in random locations. We can stamp objectives. But I want to make a more interesting terrain. And for the more interesting terrain, the variation that I call strategic terrain, the model that I'm trying to go. So I'm going to write that down real quick because I don't have this included yet in my notes. So we're going to use Perlin noise, and we're going to use a flat map. So for a basic map, for kind of a standard, desert terrain, which I just like to have in the game, we're going to use, Perlin noise. And basic. So what I mean by basic is we're going to kind of like use the y-axis. So what kind of check are we going to do? We're going to just use the highest point, the highest y-axis, or technically z-axis, because x and y are going to be used for the flat coordinate space. So the highest z-axis, and you're going to just move it down, or just obviously just check fours or some shit like that. We don't want to do checks. Obviously, we don't want to do a for loop check. What we want to do is just basically say pull. So we obviously just do high value, low value, get the highest. That's it. The highest value in the array for the z-axis. And then you just put your prefabricated thing on top. That's okay. So for strategic terrain, that could be a little more difficult, because we're going to need to somehow create. I want to have not just a flat map. I want to have kind of a map with some variation. Purposely, I want it to purposely always have this characteristic of low to high. And what I want it to have, I'll show you, is I want to have. So the one thing that I see right now is, so there's a method that I've been looking up, and we would basically generate kind of random shapes, but obviously they could still be squared, jagged edges. And these shapes would be, what I'm thinking right now, we generate shapes within our square. We generate things, and inside these, we sort of use biome mapping. So I would say I want a hilly kind of like a dune area in there. For another part, I want kind of a regular kind of curved map and add mountains in there. So we would need to sort of use prefab, but I want this to be procedurally generated. The reason I want it to be procedurally generated is because I want to utilize my algorithm to then kind of fine tune these parameters. We're not going to use parametric. I want to, so there are different challenges. Let's just show our challenge space. So down here, what I'm trying to do is like, so the black circles are the player spawn bases. The red circles are locations, objectives to capture. All right, so I'm thinking that we can break down each of these aspects as kind of like set pieces. And that's sort of going to be the difficult part. How wide will they be? How big will they be? Those have to also be parameters that can be tuned. So I'm trying to, first of all, code a procedurally generated process. And also, okay, yes, we will use what's called parameterization. So I want it to be like tune the values of we reduce the size, we increase complexity, but we're trying to tune these parameters in a way that utilizes particle exchange. The reason we want to use particle exchange is because that saves a ton of calculation. So let's go over. So the one that I have that I think is the most simplest one, is most basic maps, is the Perlin-Noise. The more difficult one is we're going to have to use segmented stuff and then somehow add them together. That's going to be difficult. Another challenge that I'm trying to do is trying to come up with, what's it called? Like little road networks, little road structures. I was thinking about using what's called those dog tracking algorithms, or like a dog step, like where it goes like that. But I saw another one by the Dwarf Fortress developer that uses something called okay, so we do the dog tracking algorithm to find the minimum distance, or the minimum like kind of tracking between 2 points. That's useful. So from there, we then want to use, what's it called, like numbers or number. So that's the difficult part, because each one you have to code it, and then secondly, this now adds time to the generation process. So as we add the steps that are away off the path, so up to 10 steps is what he recommended. So 10 steps away from the path, you can now try to add some slight sinusoidal variation through that. So then you kind of get more, what's it called? Not just straight lines between your targets. You're going to get some off-put, some distance. But you want to kind of avoid jagged edges, because if you do it just like without, but you don't want it to be obvious that it's just a sine curve. Because if players can see your algorithm and can see the code, it really just breaks it. It breaks that immersion. So that's the challenge as well. So I also want to eventually do kind of like kind of generate river terrains, but my biggest difficulty is just right now having to code those test for things that kind of make sure that everything is correct. So I don't want to generate a river going through the map in a way that I'm like, okay, that doesn't really look that fun. But variation is always useful. Variation is always fun. So that's just a challenge as well. So I'm looking forward to that. The hard part is it's difficult. So am I going to start the array? So am I going to make this like a square array? Am I going to start up here and start generating going down? Or how do I begin this array? And the reason that's a problem is because how you begin your coding of the game, what I've noticed, is really sets the fundamental structure of the limitations that you're going to face. So I'm trying to follow what I have. So like the algorithm, I'm trying to follow best practices. And part of those best practices is to break up calculations into the particle exchange rules. Because if we do it that way, then as I showed with I actually haven't showed you guys the UD array. So in my own coding in Python, let's just see if I have the UD array. Okay, so very, very basically, it's going to look like this. So as we have different bit values, you would add them up, and they would sort of give you your upper solution. But let's break it up for you in a clear way. Okay, this is the UD array. So if you use particle exchange rules, you'll notice that you can recursively code. So that's the benefit of doing things in the particle exchange rules. You can recursively code because these are 4 bits. Technically 2 sets of on-off, actually 4 sets of on-off. Either this is on or off, on or off, on or off, on or off. Yep, everything is a 4-bit-wise recursive structure. Everything in the entire universe, everything is 4 bits recursive. So that's why if you can code in 4-bit recursive, you now have access to do W plus, W minus, Z plus, Z minus, which is our states. And so these are the W plus states written in UD form. That's what they look like. And you can then turn the UD form into the W plus, Z plus, Z minus form. So there's 2 arrays that will save you calculations. The UD array, and then you change it to the recursive W plus, W minus array, or the WZ array is what we'll call it. If you can code in those 2 arrays, you can save a lot of processing power by having kind of pre-selected things that you know must be true. You have to code in, so it's kind of like coding in if-else statements, or it's coding purely in if statements, technically. So if these bits of the UD array are on, then that. So it helps a lot because you're no longer calculating in terms of actual mathematical values. You've done the work, you've done the math, and it pulls functions to call based on these parameters. So the UD array and the WZ array are actually the best ways to save what's called repetitious calculations. Any calculations that you need to do repetitively, common states, you use the UD array format to save calculation space. So I'm trying to limit the use of for loops and limit the use of checks by trying to come up with intelligent ways to check for these if else values. So that's how that project is going. And yeah, how are you guys doing? The 3 people in the viewing right now. What would you guys like to turn this conversation to? So I was just talking about just how I'm studying. I believe if I can code for a game, then I can further see the challenges of handling information networks. And the reason I picked a video game is because, one, it's fun. I think it'd be a really good thing to do. And it'd help to make an optimized game so then everyone can have fun with it, regardless of their computer or their specs. And secondly, it's actually very useful because, the UD array is possibly quite susceptible to hacking. And that's unfortunately something that seems quite true, because these are single bit values. The only solution to prevent the UD array from getting hacked is actually quite interesting. As I saw this one video from the reverse engineering guy who's trying to reverse engineer like the power meters, we would have to use complicated arrays that cannot be decomposed, at least readily by sight. What we mean by that is just like how these power companies are transmitting their data. We want to have that kind of data stream going back and forth from our game, from our players to the server. We want kind of just bit binary data going between server and player, because people can't decompose that. You do not know what I have coded for a 20 length, for a single column 20 length array. You don't know what these ones and zeros do. You cannot know. So that's the kind of stream that I'm trying to set up. So I need to set up the entire player information spectrum on here. Yeah, they might be able to uncover a few of them. If I have shooting state, and that turns on as 1 every time they fire, they can decompose that. So it is possible to reverse engineer radio RF signals. Yes, you can, and that's actually how. But it's hard. That's the cool thing about physics, about information theory. You can decompose analog space. You can decompose actual signals of their analog form. You can't decompose quantum space. What we mean by that is you can't decompose the binary values. You don't know what a 1 or a 0 is doing. You cannot know. It's fundamentally impossible unless you could track the analog space, the actual motion through time, the information that's happening. Notice how that is exactly what we said just happened. So if the player recognizes that every time they click the mouse button, one of these states always turns on to 1. That's what's giving away the information. So you don't want to ever give your information away in analog space. Analog space. Analog space is real time. It's kind of like that, where they can detect input to output, input to output. Analog space. Linear time. You want to have the information space coded in quantum space. And the reason I say that is because that's sort of what all these like freaking computer engineers, software engineers are like, you don't understand what quantum mechanics is. Like, yeah, it really actually is quantum mechanics. It's not quantum mechanics in terms of the difficulties and the disruptive and the noise interference. That's not the quantum mechanics that computer scientists and computer engineers, software engineers work with. No, they deal with quantized mechanics. They deal with quantized or quantum information. So information mechanics is what they should really say. And it's quite true. Information mechanics have the same, the same rules regardless of whatever medium it is. So if you want to talk quantum mechanics, that actually works for everything. And that's actually how I do consciousness tracking with the standard model. So like I said, everything is broken down to the UD array, which is 4 bits, up, anti-up, down, anti-down. And of these states, you can then describe higher order states, such as proton, neutron, with these particles. And then those states can be stored into the WZ array if you wanted to. And as you swap between these recursions, you save computation space, because you just directly call your functions as these values are changing. You don't have to calculate. You don't have to actually do the math. And one of the best applications of the UD array that I'm trying to show for the game is I'm trying to code what's called aircraft mechanics. So it's pretty cool. You don't need to do a full free body, a full force simulation for aircraft in video games. For real life, yes, you do, because you want to make sure everything is accounted for. But for video games, you can actually use gradient approximations, because is that not how it roughly works? So what I mean by that is that gradient approximations, quite interesting, is you're going to need to have, and that's what I'm setting up. So you're going to need to have a concrete knowledge of how, as the player angle theta up and down changes, and I'm gonna call phi, they're rotational. So as you go upside down, you lose lift. You now have lift in the downward direction if your aircraft has not just flat wings, but cambered wings, so curved wings. That's an aspect of like this, what I call the gradient thing. So all you have to do is keep track of these values. As the player values change, you apply a different function or a different value to their airspeed. So yes, we're going to use acceleration modeling, because unfortunately that's kind of the best way to do it, and you should not avoid acceleration, but we're not trying to do excessive calculation. Can you see that utility? secondly, I'm trying to, so we understand how to save computation space with aircraft. Surprisingly, you can save more computation space with aircraft than you can with ground vehicles. So that's another challenge that I gotta work out. I gotta debug how to have that same kind of gradient space savings, but for ground vehicles. It doesn't seem like I can right now, unless I have like the texture map or the height map for the terrain, which I should be able to have that array. It seems to me like, so if player vehicle is at a certain delta, obviously because it's like per unit space. So if delta x times delta z, you give me like that differential. So if the slope is too high, player vehicle loses velocity at x speed, or some variable speed. That's the kind of stuff that we would have to code for. Um, yeah, so we're trying to build the structure of everything. Because that's how everything works. You wanna have the structure before you start actually throwing things in there, because then when you're actually coding, you don't want to spend too much time thinking about the problem space. You want to actually be working on it. Like, all right, I got a plan. My goal is to make this array and see how it works. So broke everything down. Um, Definitely will post this to YouTube because I thought it was useful. Just a basic general refresher on what I'm doing and knowledge and stuff. So you, for being in there for so long, would you like to ask any questions? Anything at all? That's what this is. This is a period of office hours, open discussion, anything like that. Any questions? What do you think of the discussion? So yeah. None? All right. Well, I'm going to cut it short and we're going to open it up again.